conference for August 17th, 2019. It's a new type of system that we're using, testing out this particular version, which is StreamYard. And we'll just kind of work with it and see how it goes. For the conference for today, we have some tentative topics that we worked with over a little bit of time. And we also had some other tentative topics that were discussed on the first of the month. So we'll see how those things work out. So the discussion topics, of course, are patterns. And I've picked the Pattern Literacy in Support of Systems Literacy paper. It was done by Helene and Peter. And it's a very interesting type of paper. And want to take some time to just go through the conclusions of that paper and talk about a few of the aspects of and challenges really of relating from working with natural language semantics and translating that over to more formal language semantics and what that range or what that gradient might be. So that would be very interesting to talk about. The other one is the Boolean operators, and John Aubrey has been publishing quite a bit of work on cactus graphs and dynamic adaptable logic structures. And so we're going to start talking a little bit about Boolean operators, go over the Warfield augmented Boolean operations, and then see how those would relate to John's work. So with that, let me see if I can bring up the screen share and go to the paper here on it's a little bit running off the page, so let's see what we can find. Okay, there we go. I haven't found a good fit for this just yet. See how that works. That's a little better. So this particular paper is the Pattern Literacy in Support of Systems Literacy, an approach to pattern language perspective, which was presented 2 years ago in 2017, covers a wide range of concepts and aspects in the pattern and systems areas. And one of the things I thought was really kind of interesting, and just looking at the categories and subject descriptors, we have human-centered computing, collaborative social computing, human-centered visualization, and theory of computation, semantics, and reasoning, and theory of computational formal languages, and autonomous theory. These are things that I think are really key in making semantic judgments between real human-centered natural language types of information exchanges and formal languages types of information exchanges. There's a tension here that needs to be addressed, and I'd really like to explore that a little bit more as we go forward and start laying the foundation for some of the structure modeling software. We've addressed some of this before, but not in the level of detail or in the format that's been presented in this paper. So there's many overlapping interesting areas here. Not going to go through the paper parts in any detail at all, but one of the primary areas here is basically the find networks for different views and patterns. So I think this is very interesting because of the idea of actually creating patterns or understanding patterns or recognizing patterns and applying them. So when it says patterns in our head, that's probably pretty much on a natural language area for people. And then when we do pattern descriptions or explication of patterns, it's interesting to say, well, what kind of writing, what kind of language are we writing in? Natural language, or are we writing in formal language, or a combination of those? And then, of course, pattern reading, which closes the loop back, is interesting. But I think that this is a good general outline, or maybe template. But I think it would change, the specifics would change dramatically depending upon the type of language that you're using, whether it's a natural language language, or it would be a formal language. So these are the types of aspects here that are covered in the paper, which I think are very interesting. And this, of course, is one among many. Of course, then there's Peirce's pragmatic cycle that's been developed by SOA. It's been published and socialized for quite a period of time, which has a lot of interesting aspects about how things work. So go through to the conclusions on the paper and just talk about some of the parts of, let's see, the conclusions are, good conclusions. Okay. So when we're working on this part, so the relation of patterns through embodied cognition and understanding of systems explored here is an introduction to determining the importance of pattern literacy in support of systems literacy. So, and I think that's an interesting statement, but for specifically determining, is there a common group of literacy? Is there a common group of skills? Is there a common core group of activities that an individual or a system, an artificial intelligence system, would need? That's common to pattern literacy and also common to systems literacy. And I believe what this statement is saying here is that pattern literacy is that common core, and that the common core is needed to support. So you need to understand what the differences are between them would be quite interesting. So as it outlines the patterns to be understood to be potentially structured, these are things that you would approach in any specific case. And it's interesting to me is how you would, what are the characteristics and attributes of a pattern that would be adaptable over a wide range of system contexts, so that if you had characteristics, specific identifying attributes and characteristics that were common to all, or then just applied at certain areas, would be a way to start looking at some of the specific aspects of these two groups, whether it's pattern literacy or systems literacy. So let's see. So we're looking forward to getting the communities of system science, system thinking, and pattern language and artificial intelligence to work together on a pattern literacy to support systems literacy and its effect. That to me is extremely interesting, but I'm kind of wondering, where would you start? You know, what specific components would you use, and how would it basically be communicated? When I was reading this, one of the things I thought about and jumped to the forefront of my mind was a lot of the work that was done in the major systems development and acquisition processes. And a few of the people that had many decades of experience in designing and creating very large-scale systems for the federal government and other large corporations, they had developed a pattern that was fundamental in creating any conceptual system, to get the concepts down. And then once you had the concepts for the system put together, then those concepts would be translated to architectures, and those architectures would be translated to other things. So let's see. And that was a very, very straightforward type of pattern that was based on the function of the system, what the mission function of the system was. And essentially, it's just, okay, say, we need a system that's going to perform some mission. So it's a mission function. And then you would, once you had the system, first thing you would do was prepare for the mission. So whatever you had to do to prepare to go do your mission, you would do that. And then you would have a mobilization or transport or movement phase where you would move to the mission area. Then you would perform the mission. Then you would have a recovery from the mission area. And then after recovery, you'd have to rebuild, resupply, and then get ready for the next mission. It's a very, very high level pattern. But it was used in just an extremely wide variety of programs. And you could then add the context to it and use a functional decomposition through that approach to, again, recursively decompose the next mission function. So if I had a high level mission function, which was to, let's say, drain the swamp, right? Then I'd have to decompose that into submissions. Well, how am I going to drain the swamp? Am I going to, dig a ditch, use pumps, bailing water with people? However you do that, then you decompose that into subfunctions, and then you recursively add that same pattern again and again. And one of the primary benefits of that recursive pattern is everybody kind of understands what's supposed to happen. If you're missing a part, then you say, oh, well, why don't you have this part over here? And it's abstract. And so that it really, the mission pattern function really doesn't have any real instantiation until you give it into a real project. So anyway, those are some of the things I was thinking about when I was looking at this.
Joe,
Yes.
I noticed that Janet appears to be backstage. I don't know whether you've brought her in or not.
I think they just mean I'm muted when I'm backstage.
Okay, thank you.
Yeah. So, yeah, I have Janet in the stream. So I'm learning this new system. So we'll see how it goes. Well, Janet, do you have any comments so far?
Okay, so we missed the beginning, so we're not sure where we are. Is this something of Peter's that you're going through?
Yes. So this is a paper that popped up on my reading list. It was presented in 2017. There's a pattern of literacy and support of systems literacy done by Helena and Peter, which was in a way very interesting to me because of its breadth and its scope.
Right.
And so because it's 32 pages long, I decided just to kind of hit the highlights just a little bit and then talk about the conclusions in it.
Mm-hmm. Okay.
But
yeah, so I did read this paper when it came out. So.
Oh, well, good.
Yeah.
So
as did Michael, and Michael is here as well as usual. Michael is backstage.
Okay. Well, so I'm looking at this, and I'm really the thing that I'm most interested in is to try to find the hook between the natural language relationships and natural language semantics and the formal language. So, and for example, let's say in the example that I just gave about mission function, a mission pattern, a large scale design pattern that's been used on literally hundreds of major programs, is very abstract. But the thing about that very abstract pattern and its steps is you can easily communicate that in a formal language. You can make a program, you can make a computer program that goes through the steps. You can use a number of different ways to do that, but it can keep track of where things are, what's supposed to be there, whether things are there, what they're missing.
Right. I guess that's true for any pattern, for any well-defined pattern or architecture, which seem to be relatable ideas. And so, one could say that in applying it in the other direction in ISM, one is identifying patterns and architectures.
Discovering,
yes, right. So I guess you would say that it's a structural as opposed to a behavioral approach.
Well, so a pattern, you could use a pattern to define a high level structure, and in this particular case, we're talking about a process structure. Mm-hmm. It's 6-step, very simple, high-level process structure. But due to the fact that it's recursive, then on any specific instance of its application, the semantics for what it really means in that instance is based on the natural language, human language input. The engineering, the direction, the mission direction, so on and so forth. So those then, that's where the conflict comes in from my point of view. Mm-hmm. And also, as far as the theory of computation of formal languages, if we're just talking about process patterns, then those are very straightforwardly transferred into formal languages. Right. But where we run into tremendous conflict is when we start taking the physical architecture or the organizational architecture, decompose that, and then map between the functions and the architecture that performs those functions,
Right.
then that becomes a very difficult computational problem. And if it was like like a subset assignment between the two, it would be basically NP complete.
Right.
It would be a non-tractable type of computational problem.
Right.
So
That's an interesting, right. That's an interesting perspective to bring to this whole question of systems literacy and pattern literacy, where it seems like they're wanting something more. They're wanting something that might be computationally intractable in sort of expanding the, I don't know if it's the systems patterns perspective. I'm not sure about their connection between systems literacy and pattern literacy.
I'm not either, but the relationship between them is in the attempt to connect them is I think is very interesting.
Right.
But the idea of where you have any process, a stepwise process where you can have states and you have order, or with feedback loops or without feedback loops, can be fairly straightforwardly transformed into a formal language. Whereas when you have very large scale systems where you have implement the architectures to perform these ideas, then you bring in so many other aspects that are associated with the physical architecture, just besides performing the function.
Right.
Yes, the architecture performs the function, but you have to guard this particular architecture, or you have to have a logistic support for it, or you have to repair it, or it has to rest 8 hours every day, or whatever it is, right? All these other attributes that are associated with that architecture besides just performing the function.
Right. Robert Rosen made the point that that's how evolution works, that there isn't a one-to-one mapping between, to use the language now, which I think is helpful, physical architecture and functional architecture. And so when, the physical architecture, depending on the context, the environment, will start performing other functions, that opportunistically or, accidentally, and that may or may not cause problems for the original, the intended functional architecture. Yes, so the lack of a one-to-one mapping between the physical architecture and the functional architecture is very interesting lesson.
Yeah, so from that perspective, if we have, just from a very practical standpoint, you're looking at the, let's say, a series of written textual documents in natural language about what something's supposed to do. And then you have a procedural type of formal implementation of a process that's computer executable. You have those two. When you're trying to bring those together, I think there's some ways that you can address the problem of being computationally intractable by using different computational techniques. One of those would be like fuzzy logic. It's pretty well known that you can do massive linear equations and optimize over thousands and thousands of parameters. But even with our super fast computers these days, some of those large scale systems will take longer to compute than the real time of what they're trying to simulate. And if you're trying to, say, simulate the world economy and how it's going to respond, um, it's no value to find out, next week how the world economy is going to respond now. But if you, and some people have been able to translate those types of problems to fuzzy logic type of approaches, which gets them within 99 or 98 or, above a 95% answer, right? They don't get the 100% answer, but they get the 95% answer, and they get close enough within very, very, many orders of magnitude a lower computational budget.
Mhm.
So those are and so that's a kind of a mix between, in my mind anyway, between um, natural language relationships and natural language approaches and formal computation. So when you start bringing these ideas of like fuzzy logic and fuzzy ISM, and those components may fit in the middle. Now, they won't always optimize everything to the max, but they will always be good enough, right? Because you can do them quickly.
Mhm. So somewhat tangentially, but also somewhat related. Have you been following the discussion on Ontolog? I don't know how much has gotten through the regular Ontolog. The Ontology Summit planning has settled on knowledge graphs as the topic for next year.
Yes.
Oh, yes, I guess we did talk about this. And Mary was wondering about the relationship with John Aubrey's work.
Right.
This, on the one hand, John Soa, I probably said this, has been saying this is nothing new. This is, this is just semantic networks. But we actually got that into the abstract for the. We had a productive session last week, writing the abstract for the summit, saying that knowledge graphs are lightweight semantic networks.
Oh, good.
Yeah, so that hopefully will cut through a lot of the marketing mystification, and will give us a starting point for seeing, what can you get out of them, what is new, what's not new. The context has changed. Maybe it's just the demand has changed and the supporting technology has changed, and so even if these ideas have been around since the 60s, maybe enough has changed that that there is some reason to say it's an important emerging innovative development. So one thing that's very interesting is in the forum there was a discussion about basically model exchange isomorphism. And I didn't know if you wanted to chime in on that. It hasn't occurred recently, but people saying anything you can represent in a graph, you can represent in a table. And so that, and then I guess, you would add that you can represent in natural language or in logical propositions. I'm not sure. How do you bring in the linguistic form?
Well, those are very interesting aspects. And I think there's a number of issues at play. And one, and it's really interesting, it's coming from John Soa with his history with IBM and working with the folks that, developed the relational theory, because the driving, overarching constraints there were physical, the actual limits of the machine memory, and you're wanting to optimize for the machine memory. And so in working out the basis for the logic in your Cartesian coordinates and within your relational theory that really helps in reducing the amount of memory needed, but it takes a specific type of analysis of the logic to make that work.
Mm-hmm.
Also, when it gets to be very large, because you're decomposing these into different tables, and you have to then join those tables to get to look at different aspects and different views, then that background processing can also eat up a lot of time, especially when the machines were slower.
Mm-hmm.
Then you fast forward, but most all of that work was done for data processing on large corporations that had cycle times of a month or a quarter, right? Oh, I need my data next quarter. I need my data next month for me to respond to this. And so they weren't really pressed for, very quick, millisecond response time. And you fast forward to the internet happened, right? And when everybody is keeping track of connections and millisecond type of clicks and how things are working, that just simply didn't work very well. And the folks that started MongoDB, they tried to keep up with their amount of traffic they were getting on the internet with relational theory, and it just basically they couldn't make it work because it was too slow.
Mm-hmm.
And so they stripped everything down to its basics, right? And started with not a linked list, but almost a linked list type of data store. And then they built that up over time. And then there's other graph databases that are around. And so the changing hardware, changing what we can use, what we can work with, and also the changing demands, especially in the amount, the response time, the quickness of how fast this has got to happen, basically has it changed that. So, they've done some hierarchies with, distributed databases and sharded databases. So they're starting to mix them now, right? So that in certain places where you need very quick response time, you'll use something like Mongo or some other graph database. But if you need historical data or you need to have something that's like a catalog of patterns, well, hopefully those are the things you don't want those to change very fast, right? They might change over time.
Yes. Mm-hmm. I was going to say that's very interesting because the hype cycle suggests that people think that the graph approach is not, they don't see it as just promising efficiency in quick response to large scale databases or large scale data sources. They think that it's because the word knowledge is in there. They think that it somehow will, imbue knowledge or whereas that technical distinction between the slow changing and stable and the fast changing and, minimal. I'm glad we got a few pointers in the description. Hopefully it will come out strongly throughout this summit, that's the main thing that is being discussed. I think this history that, yes, you've just given it is clearer than the way John has described it, because John gets so impatient with people. He says, he keeps saying, this is nothing new, rather than addressing what has changed, in some kind of historical detail, the way you just did. Anyway, okay, I shouldn't have interrupted, but it's a really good basis.
Well, that's fine. It's no problem with interrupting. I think it's good to have this conversation.
Right.
It's when you look, over the aspects of what you can do with these technologies, and John doing the conceptual graphs way back when, he has a tremendous amount of knowledge, information, and insight into how those structures are used. One of the primary components, though, is that you really, from my opinion anyway, you really need to have a series of contextual references that are rather stable. They might slowly change over time, but you need to have those stable references. I mean, it's like I have a database of physical constants, right?
Mm-hmm.
I don't need that in a graph database, because it's much quicker and easier and faster for me to basically have that in a relational database, because those are constants. I know what they are. Everybody knows what they are. They're published. This is the foundation, right?
Mm-hmm. Mm-hmm.
But as you start working up through things that are more likely to change, and then the things that definitely are going to change, are going to change very fast, then those are the aspects that you need to assign different technologies to.
Mm-hmm.
And then those technologies, if you had, let's say, for example, an integrator that's looking for certain patterns, right? So say you have established patterns that are available that don't change very much, and you're looking for pattern matching in things that are changing very fast, right? So that's the system. So you're going to use relational databases in some areas, you're going to use graph databases in other areas, and it's just, you need to assign the proper technique, but the whole system works together to validate, or either identify or validate knowledge, right?
Right. Yeah. So so on the one hand, yeah, that was the point where you were just starting to talk about this idea of a hybrid, which is probably, where we should get quickly in the discussion on knowledge graphs, is the not an either or, but a both, and advantages of both and how to tie them together. So it's less about the model exchange isomorphism, which is also interesting and relevant, and will not need to come out in this whole learning process of the summit. But the technology of the physical technology of the relational approach versus the graph approach is sort of the starting point, and then what you do with hybridizing those so that they serve your purposes.
Yeah,
Interesting.
I guess there's kind of a phrase that's always stuck in my mind about intelligent systems or intelligent activity or knowledge, seeking knowledge, right?
Mm.
That is that all intelligent activity is large scale search. And so if that's true, then we have all intelligent activities large scale search. Then you want to be able to identify things that you've already searched and are not going to change, right? So I know that I've done this work before, and I've got this answer, and I know what this means in this context. So you don't have to research, you do that over and over and over again every time. So you start building those patterns up.
Mm-hmm.
And so as you're looking at that large scale search, really, when you're going from a stable type of architecture, things that don't change or don't change very much, through things that are using as markers to validate and verify other patterns that are coming in from fast changing experience, then when you design that whole system, you design it to minimize the cost and maximize the speed of the large scale search. So
Right.
as soon as you can identify stuff that you already know and it has a very low probability of changing, you won't search that anymore, right?
Mhm, mhm.
So that kind of stuff. It's
Oh, right. That's excellent. I'm wondering if you want to do a presentation on this. How can you connect the things you've been saying to your work? Um, uh,
oh yeah, well,
because
it's I mean, so structural modeling basically has got the two parts, right? It's got the the design mode and the discovery mode, right?
mhm,
And so when you're in discovery mode, you have your basis, like I was talking about, large scale search. You're searching for patterns that people understand, recognize, and fulfill some criteria. That's what your goal is. You're going for that. And then once you have confidence, you start building a level of confidence that you're getting close to what you want to do. Then you start doing some preliminary design, and then you start testing that design, right?
mhm.
It's kind of a phased thing. It's pretty much standard systems engineering, but people have a tendency to get caught up in just uh, a specific aspect or one phase of systems engineering and not get outside and look at the whole very large scale integration.
Mhm.
So it's
So your
right?
starting topic here with the patterns then
Yeah,
has turned out to be really key to making sense of knowledge graphs and graph versus relational databases and patterns and intelligent systems. So the patterns, searching for the patterns.
right. Yeah. So you have some for context. You have to have some community, right? I think I read this morning you were saying, well, if you're going to hold someone negligent, you have to have someone from their community of practice say that they violated the pattern, right?
Right, exactly.
So
Yeah.
those patterns basically are stable. They're
Mhm.
validated in context by a community, and so you're not going to search those every time. You're going to kind of know what they are. They'll slowly change over time, but not very fast, right?
Right.
So those are the types of things I think are important when you're designing a very large system, how that's going to work.
Right. Yeah, that's so beyond. I don't know if Peter and Helen address this, but the question of um, the speed of change of the patterns. So beyond just, I think both in pattern thinking and systems thinking, there's too much focus on just sort of the fact of patterns rather
Right.
than getting beyond that to asking questions like how quickly do they change and what does that mean in different contexts and how can you work with that? What does it show? If they're stable, if they're redundant, if they're yeah.
So it's very interesting. I think there's been quite a bit of work in the software patterns area where people um, came in and found that did a lot of, let's say, patterns work in for the Java language, which was a typed language. It was compilable with bytecode type of compilation and executable. And it had all of these specific attributes of this executable language. And then they built patterns on top of that. But then they moved off and they would do something like JavaScript or Python or C or some other language. Then they found that many of the patterns that were developed for Java implementation were not required in these other languages because these patterns were just used to go ahead and make up for, in air quotes, but to address quote unquote usability deficiencies in the language, right? So so the context is important, and that's why the context for software patterns in Python, this probably won't change very much. Java won't change very much, but there's differences between the two, right?
Mhm.
In JavaScript, there's changes, right? So those are things that you really, once you kind of understand what you want to do and you pick the context, then you don't need to search everything. You can focus in and not search stuff that's irrelevant.
Mhm.
So those are things that are important.
Right. We never even got, so context was the topic for the Ontology Summit 2 years ago.
Mhm.
And we never even got to this connection between context and search that you're bringing out there. I, yeah, it's a little frustrating. There's, these are sort of squirrely topics, and there isn't really, people make presentations on their own work that is vaguely related to the topic, but there isn't a, there's not really a study effort where people can sort of synthesize. Ken McCloskey, who's running it, has has expressed his sort of dismay and frustration at how there's the integration keeps being overlooked, the and how difficult it is. So I don't know if you can come up with a topic that you'd be interested in presenting on, relating your work to all of this wisdom that you've been sharing on knowledge graphs, but maybe you'll see as the topics develop.
Is this? This is
What's that?
This is the Ontology Summit.
Yeah, why don't you go to the website Ontology Summit 2020?
Okay, I'll go and take a look after we're done here. But I agree with you that it's difficult. One of the things that I learned over a period of time, especially working with extremely large scale systems, was that there are thousands and thousands of people that call themselves systems engineers.
Mm-hmm.
But due to the size and complexity of these systems, an extremely small percentage of those individuals have purview of the total system.
Mm-hmm.
And then the ones that do have purview of the total system usually are very, very active during the initialization, conceptual design, and detailed design. And they kind of disappear after the detailed design when it goes to production and implementation.
Mm-hmm.
So you have people that are very cognizant of integrating all the concepts up front of what the system has to do, getting that ready, getting design done. They kind of disappear. And then when the architecture starts being developed, that's going to perform all these functions,
Mm-hmm.
that integration basically is, and the people that know how to do that are very rare because it is so context dependent. And so they have a tendency to start from the back end and integrate by test, because really that's the only practical thing that a large scale community knows how to do. And so what Ken is bemoaning here about the very large scale approaches is common.
Right.
And so it's, but
right. Well, I think this is, this is the work you guys have been doing, and Jack he's been promoting the idea of a whole systems modeling approach.
Oh yeah.
So, and then this is what I'm trying to bring out in that discussion about professional negligence is if we could get the need to do whole systems modeling in as a standard for systems engineers,
Mhm.
then that would be a huge improvement. And so I get frustrated when people talk about ethics. It's that's just wishful thinking. But if you can say here's a technology and a method that it's expected that you will use this in trying to understand the whole system's integration throughout the life cycle. That's a real feasible step. That is, it's just we don't know how long it's going to take for that to become standard. But I imagine that it probably won't take that long, because using things like the what Warfield started and what you've been working on, if there was a will and an interest and a recognition of the value of it, then you would think it could be integrated as part of standard systems engineering practice.
It could be. There's some problems associated with standards, and of course one of them, and with certifications as well. That is things don't keep up. They don't change fast enough because they're in a very fast-paced changing area. But you could have knowledge blocks that maybe are not so tightly bound to each other as they are now, that people could adapt. So there's a lot of things that could be looked at there. It's been
Well,
my
I was thinking more of the use of ISM, say,
Mhm.
as a standard. That is not changing.
Oh, well, yeah. ISM and structural modeling definitely can be used as a discovery type
Right.
of mechanism, right?
Right. A discovery and a what would you call it? A self-criticism, sort of an ongoing reality check.
Well, it's a generic design. It's the science
Yeah.
of generic design.
Yes, there you go.
It's
Whichever
not,
one of these, right?
yeah, it's not the science of a specific design. So it's not the science of, computer design or airplane design or train design. It's
Right.
generic. So it could
Right.
definitely apply.
Okay. That's the phrasing. That's the characterization that I should be focusing on, is the science of generic design.
Yep. So I see Kevin has joined us. Have any comments, Kevin? Okay. So getting close to got about 7 minutes more to go here. So I'm going to stop sharing this screen and then bring up the next screen on. Okay, where'd you go? Now I need to find it. Here it is. Application window, bring up this one. Okay. So this comparison of decimal and Boolean operators from our structural modeling framework paper that we presented in 2015. But wanted to not only show this again to highlight the similarities and differences between decimal operations and Boolean operators. The only difference here is this one, where 1 + 1 = 2 in decimal and 1 + 1 = 1 in Boolean. And Warfield augmented these Boolean operations by adding greater than or less than. So it took the Boolean measurement scale out of nominal space and put it into ordinal space. And so these are the operations that I'm going to try to map to John Aubrey's dynamic Boolean operations. I'd hope to make more progress on that for today, but I simply was unable to get it completed. So push that out till, let's see, the September, which is the first Saturday in September, whatever that is, on my new computer here, and things aren't set up yet. So here we go. So we want that would be the 7th, the September 7th, the first Saturday. So my plan there is to go through and map the operators that for distinction and inequality that operators put together, and also from the laws of form, and see if these actually make any sense in comparing the two. And if that works out to be fairly straightforward, then there ought to be a connection between what we're doing with our abstract relation types and the work that Aubrey's doing with his dynamic logic. And just as as a aside, we were talking about the difference between the natural language and the formal language and the complexity between those. And that's I'm exploring whether or not this type of dynamic logic would help in integrating those differences. And so that would help in where you have the conflict between very well-defined executable logic languages and natural languages. And so it appears to me that where natural languages, you have some flexibility and some differences, and you can change things according to context. The dynamic part of the work that John has done would be want to explore that and see if that can be applied similar to fuzzy logic. So it's kind of the plan for the 7th. Are there any comments, questions? Okay. Well, this appears to have been a successful test of the StreamYard. We'll try that again on the 7th.
Joe, I got a mention for you. I don't know whether you've seen the chat messages, but Kevin has been on his phone and unable to see anything, and it's been choppy and drops out from time to time.
Okay.
He's also on Safari and it wants Chrome, and his
Right.
storage is maxed out. So I suggested that, in fact, indicated that you'd run into the Safari versus Chrome issues early on. So maybe you and he could communicate in between.
Right. So just as a pointer, I guess, for people that were planning on joining on the 7th, is I had similar issues. I had to use Chrome to get a type of sound quality that was usable. I was getting sound on using either Firefox or Safari, but it would drop out. Chrome basically has been very good. I also had to get an external mic and external headphones and hook up my computer wired as opposed to wireless. And those are all things that the service suggested that I do. So it went from being basically unusable when I tested it the first time to being fairly usable now. So, but I will definitely work with Kevin whenever he wants to see if we can test something out and get it working.
Yeah, I'm on Safari on my iPad, and it has been fine. It occasional pops and clicks and little bit of choppiness, but not extremely more so than any of these other systems. So
Oh, good. Excellent. Well, I'm glad that we've had a successful test, and we'll look forward to September 7th, and hopefully we'll have some more interesting topics to deal with, and I'll hopefully have some more progress on the Boolean operations and the
Right.
mapping.
Very good.
All right. Take care and talk with you next month.
Thanks
Bye-bye.
to all. Thank you, Kevin.